Alright guys, welcome to the 1-5 video. We're talking about adding and subtracting real numbers. So after this lesson, I want to be able to find the sum, which is the answer to an addition problem, and the difference, answer to a subtraction problem, of real numbers. Now here we go. We got a little getting ready here. So if you kept track of the activity on a gift card shown at the right, the values are negative in red and when you spend money and positive in black when you add money. You want to give the gift card to a friend. How much money must you add to make the card worth 25 bucks? Explain your reasoning. So take a second, pause the video, and go ahead and answer that question. Make sure you explain your reasoning. All right? Pause it. Give it a shot. When you're ready to come back, here we go. We're back. So to solve it illustrates some numerical relationships that are always true for real numbers. So we can add and subtract any real numbers using a number line model. You can also add or subtract using rules involving absolute value. So maybe some of these things you're already good at. It's just kind of good to confirm what you may already know. So if we look here at the next box, as problem number 1, using a number line model, what is the sum of each? And just kind of cement this idea into your head. So here we go as we look through. So the sum, answer to an addition problem, of 3 plus 5. So we know what direction to move along in the number line. If the number added is positive, move to the right. If the number added is negative, I would move to the left because positive numbers are to the right on the number line, negative numbers are to the left. So if I want to take 3 and I want to add 5, well, 5 is positive, so I'm going to add to the right. So start at 3, move to the right, should be 8. In B, I'm going to start at 3, but then I'm going to add a negative 5. So when I start at 3, I'm going to move left 5, and I'd wind up at negative 2. So 3 plus negative 5 is negative 2. In C, start at negative 3, add 5, so move to the right. So moving to the right, negative 3 plus 5 would wind up at 2. And in D, start at negative 3, move 5 to the left because of the negative 5, and I'd wind up at negative 8. So negative 3 plus negative 5 is negative 8. Okay, there's a couple for you to try on the bottom, so go ahead and give those a shot. Make sure you fill those in, that you got it, so we can know that you're doing the right thing. Okay? So, one of the key concepts to understand is absolute value. So the absolute value of a number is its distance from 0 on a number line. All right, so pretty easy concept. The absolute value is always non-negative, which means it's either positive or it could be 0, since distance is always non-negative. All right, I can't walk negative 4 miles. All right, for example, the absolute value of 4 is 4, and the absolute value of negative 4 is also 4. And to understand that, let's look at a number line. So there's a dot at 4. He is 4 units away from 0. If I put a dot at negative 4, that is still 4 units away from 0. So remember, absolute value is the distance from 0, how many units away from 0 he is. So the absolute value of 4 is 4. The absolute value of negative 4 is also 4. We write it as 4 with some bars around it. So we put these two little bold lines on each side, and that's how we write absolute value. So the absolute value of negative 4 is 4. So when you see these bold lines, that's what it's talking about, absolute value. We use absolute value to help us understand adding and subtracting real numbers. So here we go. When I add numbers that have the same sign, add the two numbers by adding their absolute values, and the sum has the same sign. So 3 plus 4, well, they're both positive. So I can just add 3 plus 4, and I get positive 7. Negative 3 plus negative 4, well, their absolute value is 3 and 4, so just add them together. And the sign that they both have, because they have the same sign, is what I keep. So 3 plus 4 is 7, negative 3 and negative 4, both negative, so negative 7. All right? If they have different signs, well, then I'm going to subtract their absolute value. The sum has the sign of the bigger absolute value number. So, for example, negative 3 plus 4, well, they have different signs. This is a negative 3 and a positive 4. So subtract, and I'd get 1. 4 is bigger, so it would be a positive 1. 3 plus negative 4. Well, there's a positive 3, there's a negative 4. So subtract them, I'd wind up with 1. The bigger number is negative 4. So I'd have a negative 1 as my answer. Okay? When I go to add some real numbers, here's a little bit of practice. Okay, so negative 12 plus 7 would just be negative 5. Okay, they got different signs, so I would subtract them, put the sign of the bigger absolute value. Negative 18 plus negative 2, same sign, so add them together, take the sign you got, negative 20. Negative 4 plus 8 plus 9.5, different signs, so I got to subtract them, put the sign of the bigger. 3/4 plus negative 5/6, so different signs, subtract them, put the sign of the bigger. A little fraction work here. Okay, so in order to subtract or add fractions, you need a common denominator. So we just turn that into 12 and that into a 12 by changing the tops. All right, so if you need help with that, please ask in class. Two numbers that are the same distance from 0 in a number line but are in opposite directions are called opposites. A number and its opposite are called additive inverses because when I add them together, I get 0. The sum of a number and its opposite, if you use you can use the inverse property of addition. So that basically says if I take a number and its opposite and I add them together, I'm always going to wind up with 0. So 14 plus negative 14 is 0. All right, so that's just another property that we can add to our into our work from 1.4. All right, negative 14 plus 14 is also 0. Right? There's two numbers who are opposites, and if I add them together, I always get 0. Okay? We can use opposites to subtract real numbers. So let's see what that looks like. So if I wanted to consider 3 minus 5 or 3 plus negative 5, right? So I started at 3, I go back 5 units. That's what they would tell me to do here from the work in the very beginning of this section. 3 plus negative 5 would put me in negative 2. That's the same thing you'd get if you did 3 minus 5. Okay? So when I subtract real numbers, I just add as opposite. So if I have my addition rules from before, I can think of subtraction as just addition of the opposite. So for example, 3 minus 5 is the same as 3 plus negative 5. Now apply your rules. They have different signs, so subtract them, put the sign of the bigger, which would be negative 2. 3 minus negative 5, well, the opposite of negative 5 is positive 5, so this problem would turn into 3 plus 5. Now they have the same sign, so you can just add the numbers together, keep the sign you got, which would be 8. All right, so a little bit of subtraction work. Negative 8 minus negative 13, well, that would be negative 8 plus the opposite of that, which would be positive 13. Now they have different signs, so I would subtract their values. I get 5. The bigger one is 13, so I would keep it as a positive 5. In number B, 3 plus 5, 3.5 plus, well, the opposite of that is, so 3.5 plus negative 12.4, well, 3.5 plus negative 12.4 is negative 9.8. So different signs, subtract them, right? And then take the sign of the bigger number. All right, 9 minus 9. Well, really, that's 9 plus negative 9, if you think of it like that. So this is a nice illustration of how the rule works. We all know that 9 minus 9 is 0, so understand what they're trying to do. Add the opposite of 9. So if I added the opposite of 9, 9 plus negative 9 would just be 0. 4.8 minus negative 8.7. Well, 4.8 plus the opposite of this number would be 4.8 plus positive 8.7. They're both positive, add them together, keep the sign you got. Okay? And then problem number 4 is like an application to these ideas. A reef explorer dives 25 feet to photograph brain coral and then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. Then the diver rises 29 feet to see an underwater cavern. What is the location of the cavern in relation to sea level? Okay? So if we wanted to represent the problem with an expression, start with my 0 to represent sea level. So when I'm at sea level, I'm going to think of that as 0, and I'm going to subtract when I go down or dive, and I'm going to add when I come up or rise. So in the beginning, I'm starting at 0. I'm going down or diving 25 feet, so minus 25. I'm coming back up, rising 16. And then I'm diving again 47, so minus 47. And then I'm rising again 29, so plus 29. So really, it's just a big arithmetic problem. Got a calculator, go ahead and just punch all that right into your calculator. Sometimes it's easier to kind of help yourself organize a little bit. So 0 plus negative 25 plus 16 plus negative 4.47 plus 29. So we just applied the rules of turning subtraction into addition of the opposites, and it would look like that. And I would wind up with 45 plus negative 72, which is just negative 27. So again, for a lot of these things, you have a calculator. All right. The main goal of this section is to help you understand why the things work. If I'm doing this problem, I'm taking this and punching it right into my calculator. All right. If I'm doing these problems, I'm punching them right into my calculator. The goal of the section is to understand why that works. Okay. Why is 3.5 minus 12.4 really the same as 3.5 plus negative 12.4, and how all that comes about. Okay? So the cavern is 27 feet below sea level. All right? Thanks. Hopefully you knew some of this before. If not, hopefully you picked it up. If you knew it before, hopefully it just kind of confirms and helps you understand the math behind it. I'll see you next time. Peace.